Hello students, welcome to Purnang. So today again we are back with two questions on algebra. First one seems to be a question on binomial and series, and second one of course seems to be a question on complex numbers. So let's start quickly with the first question. See, the statement of first question is we are given the value of a series where r is the variable of the series that goes from 0 to 9, and it is summation over 20c to r into 20c to r plus 2. Okay, and this is given to be p upon p plus 1 times, and what is it? This is 39c21 minus 19c10 if I'm correct. Okay, so that's it. Now see how to start it. If we see, that's what I always say whenever I come across a question on series, and if I'm not able to apply any result, any formula, then what do I try is I try to open the series. But before that, there seems to be a formula which we can think of applying it, like it's 20. If I write it as 20 minus, yeah, okay, yeah, 20 minus 2r, and this I write it as 20c 2r plus 2. Now observe one thing. What need to be observed is sum of subscripts of both the binomial coefficient is a constant, and that is 22. So independent of r, whatever value of r you put here, the sum of subscript remains constant, and for that we have a result. What I say, it's like mcp into ncq, where p plus q is a constant. Remember this. So the result is m plus n, sum of superscript, c, sum of subscript, which is a constant. But that result you can use only when you have all possible terms of the series. Here the point is, do we have all possible terms? Answer is no. Because why? See, just open it and you will find it out. So when you put c, r is equal to 0, it's 20c20 into 20c2, plus r is equal to 1 is 20c18 into 20c4. Similarly, r is equal to 2, so 20c16 into 20c6. Are these all possible terms? Of course not. We are missing odd terms. What are we missing? Like we are missing here 20c19 into 20c3, and here similarly we are missing here 20c17 into 20c5. All odd terms we are missing, so we can't use this result directly. Okay, so now for that case I will suggest you to go to the basic from where we get this result, and that is go to the expansion of 1 plus x raised to the power 20, and then write it as 20c um, 20 x raised power 20 plus 20c19 x raised power 19 plus 20c18 x raised power 18. I will be writing few more, 20c17 x raised power 17, and so on and so on. Now you should write here the expansion for, again I'm writing the same thing, 1 plus x raised power 20. Doesn't matter if you write x plus 1 or 1 plus x, is the same thing. What matters is the way we need to collect the term. 20c0 plus 20c1 x plus 20c2 x square plus 20c3 x cube, 20c4 x raised power 4, and so on and so on, plus 20c5 x raised power 25, and so on. Okay, now multiply these two. When you multiply these two, you get in LHS 1 plus x raised power 40, and in RHS you get several many terms, of course, but we have to collect these terms. We are looking for these terms, and now the sum of subscript is 22. You can collect these terms as the coefficient of x raised power 22. Let's start. So this into, where is it, x squared, this one. So first term, if I collect the terms for x raised power 22, there will be several many terms, dot dot dot. I'm just collecting the terms for which are the coefficient of x raised power 22. So you get it as 20c20 into 20c2. Next one will be 20c19 into 20c3. Then it would be 20c18 into 20c4, 20c17 into 20c5, and so on and so on. Okay, so of course it's a identity. So the coefficient of x is power 22 gives you a series in RHS. In LHS, the coefficient of x is power 22 is 40c22. So this is equal to what? Some 20c20 into 20c2 plus 20c19 into 20c I think 3, yeah, 20c18 into 20c4, and so on and so on. Okay, now similarly rewrite the things again. 1 plus x is power 20. I'm rewriting the series 20c 20x is power 20 and so on and so on, not writing it again, but here I will write 1 minus x is power 20. So you get it as 20c naught minus 20c 1x plus 20c 2x square minus 20c 3x cube. Now again I will ask you people to collect the terms for x is power 22. So in LHS when you multiply, it's 1 minus x square raised to the power 20. In RHS when you collect the terms for x is power 22, now you get the same series but with alternate sign. So it's 20c20 into 20c2 minus 20c19 into 20c3 plus. So I think now you all got the idea how to approach, isn't that? सारे बच्चे अब समझ गए होंगे आगे क्या. Now we have these two. Now here again, of course on comparison you get it's the coefficient of x is for 20 in LHS would be 20c11 but with negative sign, and this is equal to 20c20 into 20c2 minus 20c19 into 20c3 and so on and so on. Just add these two, add the second one, and if I call it the first one here, add these two. So what do you get? 40c22 minus 20c11 is equal to 2 times the event terms. That's our series what we want. Okay, so therefore value of r goes from 0 to 9, 20c2r into 20c2r plus 2 is half times बच्चों. Half times how much? Half times 40c22 minus 20c11. But just you need to get it in this form here. So 40c22 can be written as 40 by 22 into 39c21. Similarly, what was that? 20c11. Okay, that could be written as 20 by 11 into what? Into 19c10. Isn't that? You simplify it, you get 20 by 11 here also. So in nutshell, what do we get? So the series which we need is half times, and this is we get 20 by 11 common. Okay, and then we have 39c21 minus 19c10, I suppose. Yeah, so we have 10 by 11. You compare it, so of course p is 10 here, and that's the answer for the first one, bachon. So I definitely like this question when it came as a doubt in front of me. Now moving to the second question. It's a complex number question. Given that mod of z1 square is 5 and argument of z1 is between 0 to 5, that means it lie on the upper half of the argand plane. Okay, bz2 and cz3 are fixed points which are roots of what's the degree of this equation. It has 4 roots, and we have to just get two of them, and whose arguments are in the interval minus 5 to 0. That means we need to consider those 2 points which lie in the lower half. Find circumcenter of the triangle ABC and also find the fixed point to which the internal angle bisector of angle A pass here. Okay, so if I start with, see, mod z1 square is equal to 5. What does that mean? That means z1 lie on a circle whose radius is root 5. First information. And also on the in the upper half of the Cartesian plane. Just a minute. Okay, and in the upper half of the Argand plane. Sorry. Okay. Now the equation given is, just try to solve it, okay, using Shidhachar formula. So z square is minus b, z6 plus minus b square minus 4ac, 100 minus 36 is minus 64, 8 iota by 2. 4 rather 3 plus minus 4 iota z square. So z is how much? Z will be its square root. Now its modulus is how much? Its modulus is 5. So mod of z would be, I think I'm clear, all the roots which you will get as the square root of 3 plus 4 iota and 3 minus 4 iota, they have modulus as root 5. So this implies the roots of this equation which happen to be z2 is also root 5, which happen to be z3 is also root 5. So they all lie on a circle of radius root 5 and center as the origin. And of course in that case what? The circumcenter of this triangle is what? The origin itself. So first one is done. So circumcenter is origin itself. Now why did I pick this question? I picked up this question just for the second part where we have to prove that the internal angle bisector of angle A passes through the fixed point and we have to find that point. Okay, for that I will say, let us assume point A to be here. So I'm drawing another figure here. So let me assume point A to be there. Now draw the internal angle bisector which meets the circle at point P. Join BP बच्चों and join PC. Since it is an internal, it is an angle bisector, so this angle is theta, this angle is also theta. So angle BAP and angle PAC both are theta here. Okay. Now that, what does that mean? If I draw this here and here. So angle subtended by the chord on any point on the major segment is half the angle which is subtended at the center. So this has to be 2 theta and this has to be 2 theta. 2 theta, I think all of you will agree to this. Now consider triangle BOP and triangle POC. Aren't they congruent? They are congruent triangles, bachcho, isn't that? They are congruent triangle by the criteria SAS. Side angle side. OB is equal to OC. OP is common. In any case, OB is equal to OP is equal to OC. And angle between BOP and POC is same. So side angle side criteria, we can say that the triangles are congruent. That means by CPCT, PP is equal to PC. Now, what does that mean? That means BP arc, if the chords are equal, arc are also equal. So BP arc is equal to PCR. So the midpoint, therefore, midpoint of arc BC. Since B and C are the fixed point, don't forget that. So midpoint of arc BC is that fixed point through which the internal angle bisector of angle A pass. Okay, so those were the two questions for today.